So this is a continuation of 6.3. Basically, we're going to be talking about arc length. And so from geometry, we need to remember that an arc was a part of a circle, and that a central angle is an angle where the vertex is the center of the circle. So the length of an arc depends on the radius of the circle and the measure of the central angle, which we're going to call theta. So as you see below, to find the length, or your arc length, you're going to use L equals R theta, where R is your radius and theta is your central angle measure. And the measure needs to be in radians. So we're using radians as opposed to degrees. So in example 5, it says that the second hand on a clock is 6 inches long. How far does the tip of the second hand move in 15 seconds? So we're looking for how far the tip moved in 15 seconds. So we're looking for L. So we're looking for the arc length. Now, in the problem, they give you that the second hand is 6 inches long. Now that 6 inches is your R, because your second hand goes out to the edge of your circle. So you have from the center to the edge of your circle. So that gives you your R. So we need to think about what we know. So we know that one revolution equals 2 pi. Right? For any circle, if you go around the whole circle, you've gone around 2 pi. And for a clock, we also know that one revolution equals 60 seconds for the second hand. Because you go around, the second hand goes, when it makes a full rotation, it's been 60 seconds. So we need to find 15 seconds. So we've gone around 15 seconds and out of the 60 seconds. So that's 1/4. So we've gone 1/4 of the circle. So now we need to get that into our radians. So if we've gone 1/4 of a circle, we're going to multiply that by the 2 pi. And like Nick said, we've gone pi over 2. So that's our angle for theta. So now using our equation, we have L equals R theta. We're looking for L, so we found our R is 6 times the pi over 2, which was our angle. So we get 3 pi for a length. Now that's kind of a weird length, so I would actually multiply this out, and you get approximately 9.4. Now that 9.4 is in inches because our second hand was in inches. So units are important on these. So we found that in 15 seconds, the second hand moves about 9.4 inches around the circle. So now our next example gets a little more complicated. It says a car is traveling at a rate of 25 meters per second. If a tire is 40 centimeters in radius, find the radian measure of the angle through which the wheel turns in 2 seconds. Okay, so we're given a rate of 25 meters per second. We're given that a tire has a 40 centimeter radius. So this 40 we know is our R. And then then it says find the radian measure of the angle. So we're looking for theta. this time. This time we're looking for theta. So we're given an R, and we're given some other information, so we have to find L. So to find L, we're given a rate, and we're given a time. So rate is meters per second, and then we're given that it's turned for 2 seconds. So to find distance, we can remember that distance equals rate times time. Or in this case, our distance is length. So we're going to use our rate, which was 25 meters per second. And we're going to multiply that by the 2 seconds that the wheel turned. So our seconds are going to cancel out, and we're going to get a distance of 50 meters. Now, our R is in centimeters, and our L, or our D in this case, whichever you want to classify it as, is in meters. So we should probably get those into the same measure. So we're going to convert this 50 meters to centimeters. So for every 1 meter, there's 100 centimeters. So you get that you have 5,000 centimeters. So for your L equals our theta, again, we're looking for theta in this problem. So our L we just found is 5,000, and our R was the original 40 centimeters that we were given, multiplied by the theta. So we're going to divide by 40, and you get theta equals 125. Now this 125 is your radian measure. Nowhere in here did we go to degrees. Remember that in this equation, you're finding it, theta in radians. So this is 125 radians. You don't have to put this radians, it can just be 125. But so you remember that it's radians, you might want to write it down. So that's it for the notes, but we're going to go over the homework.